Students, now let us take question number 5 of exercise 12.1. Maximize z is equal to 3x plus 2y subject to x plus 2y less than equal to 10, 3x plus y less than equal to 15 and xy greater than equal to 0. So firstly we need to consider their linear equations. So x plus 2y is equal to 10 and 3x plus y equal to 15. For plotting the graph, y is equal to 10 minus x by 2. Just make the table x0, y5, y0, x10. For this equation, x0, y15, y0, x5. Okay. Now let us check the origin by putting x and y0 both in equation number 1 and 2. So 0 plus 0 less than equal to 10 means, yes, it is possible, it is true. So origin is satisfied. That means shading is towards the origin. And here 0 plus 0 less than equal to 15, again the shading is towards the origin. And this less than equal to sign says, as both the equations have this less than equal to signs, that means the curve feasible region will be bounded one. Okay. So let us plot the graph, and the graph is like this. This is your graph of line 3x plus y less than equal to 15, and for this it is x plus 2y less than equal to 10. Okay. And since the shading is towards origin for this line, towards origin for this line, and we work it out, we get this quadrilateral as the required shaded portion. So what are the corner points here? 0, 5, B is 4, 3, C is your 5, 0, and the origin itself 0, 0. Using corner point methods, the corner points are there, and we will evaluate this objective function z is equal to 3x plus 2y. For this it gives you 0. For 0, 5 z is 15. For 4, 3 it gives you 18. And for 5, 0 it gives you 15. And this is the required maximum value. So z is maximum at x is equal to 4 and y equal to 3, and the maximum value is given by z is equal to 18. Okay. Now since this b, you will plot it on the graph. So this b is 4, 3 and can be located on the graph easily. Otherwise, for these points, if say they are not simple points, for this you can solve these both these equations by using linear equation in two variables, like this x plus 2y equal to 10. Make its equation 3x plus y equal to 15, and just multiply, equating the coefficients, multiply this by 3, or you can make y also equal. So we can get, by solving them, we can get y 3 and x as 4, means the point can be taken. So question number 6. Question number 6 is minimize z is equal to x plus 2y subject to 2x plus y greater than equal to 3 and x plus 2y greater than equal to 6, xy greater than equal to 0. This is 1, this is 2. Corresponding equations are 2x plus y equal to 3, x plus 2y equal to 6, and this gives you area lying in the first quadrant. So from here y is equal to 3 minus 2x. When we will frame the table, x0 will give you 3 and y0 will give you 3 by 2, that is 1.5. Here this is 6 minus x by 2. So x is 0, you will get y as 3, and when y is 0, x is 6. So let us check the origin from these inequations. Put x and y both 0 here. So 0 plus 0 greater than equal to 3. 0 is greater than equal to 3? No, it is wrong. So origin is not satisfied. That means shading will be away from the origin. And here 0 plus 0 greater than equal to 6. That is 0 greater than equal to 6. Origin is also not satisfied. Hence this shading will also be from away from the origin. Okay. And also both these signs are as greater than equal to. So this curve feasible region will be your unbounded one. Okay. So let us plot. And after plotting, this is your line 2x plus y greater than equal to 3. Shading will be towards this side. Okay. And for this x plus 2y greater than equal to 6, again towards this side. But we need to take into consideration those non-negative constants x and y greater than equal to 0. So this will be the required, see, this boundary. Okay. You cannot go in any other quadrant, and it must contain all the lines. Okay. So this is the common shaded portion, which is your unbounded one. So corner points, the two corner points are there. One is 0, 3 and other is 6, 0. So let us apply the corner point method. It gives you for 6, 0, z is coming out to be 6, and a 0, 3, it is coming out to be 6. This is b 6, 0, and this is a 0, 3. Now see, what do you find? That z is equal to 6 is at 2 points. Okay. It is clear z is equal to 6 is occurring at 2 points, a 0, 3 and b 6, 0. Okay. So if we take any point, so what is the meaning of this? That means here also you are getting your desired value. Here also you are getting the desired value, and both the values are same. So that means on this whole line joining, you will get the same value. Okay. So your desired value is occurring on this complete line joining. Okay. Line joining these two points. So if we take any point on this line, you can also check it by taking any point on this line. That will also give you the equation value as 6 itself. So you can take 2, 2. Okay, graphically if you will plot it on the graph, you will be able to locate 2, 2 on this line. And for this also, this x plus 2y is giving you the value 6, that is z is equal to 6. So this was the required value, which is minimum z is equal to 6. As no other value is occurring, so minimum z is occurring at 2 points. So that means it is also occurring on this complete line joining the points 0, 3 and 6, 0. Okay. If it is occurring at this 2 points, same point, that means on the complete line joining these 2 points, your minimum value is occurring. Okay. So let us take now question number 7. This is your question number 7. Minimize and maximize. You need to find both the maximum and minimum value for this function. Z is equal to 5x plus 10y objective function, subject to x plus 2y less than equal to 120 and x plus y greater than equal to 60 and x minus 2y greater than equal to 0, and both x and y are positive. They are your non-negative constraints. So given constraints are, name the equation 1, 2, 3. Corresponding equations are x plus 2y equal to 120, y is 120 minus x by 2. And from this table you will get for x0 y 60, for x 120 y is 0. Okay. And checking of the origin says 0 plus 0 less than equal to 120. Okay. So 0 is less than equal to 120. That means it is true. So origin is satisfied. That means shading will be towards the origin. For this, y is 60 minus x, two values, x0 y 60, y0 x 60. Now let's check origin. 0 plus 0 greater than equal to 60. Is 0 greater than equal to 60? No. So origin is not satisfied for this second inequation. For third one, x minus 2y greater than equal to 0. Now this is a kind of line, x is equal to 2y. Okay. So you will find that this line itself passes through origin 20 and this is 40. Okay. So since it passes through origin, so origin checking is not fruitful here. Okay. So let us see the graph of this system. This is your x minus 2y greater than equal to 0. This is the line. X plus 2y less than equal to 120, origin is satisfied, so shading will be towards this side. You have to keep it in mind. Okay. And for this inequation, x plus y greater than equal to 60, origin is not satisfied, so shading is towards this side. Okay. And this is the line which is passing through origin. So see, this line has divided it in 4 portions. Okay. This 1, 2, 3 and 4. So I just need to locate whether which part is the feasible region for this question. And for it, you know it very well, we have done it in class +1 also, linear inequalities, that we need to consider a point, okay, here, and we will check whether it is satisfying all the conditions or not. And after checking, I'll find, say I have taken one point 80, 10 here, 80, 10 here, okay. Consider the points here also, but they are not satisfying all the 3 conditions. So 80, 10 from here and see how it has worked. See, I have written here that x minus 2y greater than equal to 0. These are the 3 inequations which need to be satisfied. So, consider point in region 1, 2, 3, 4 such that x is greater than equal to 2y. Okay, you have to consider that point for which x is greater than equal to 2y. Now, if you can locate a point which satisfied these 2 other conditions also, then that portion will be the solution region. Okay, now we have taken one point 80, 10 in region number 2 and we found that it is naturally working out for this 1, that is 80 is greater than 2 times 10, and also it is satisfying this your x plus 2y less than equal to 120. 80 plus 20, that is 100 is less than equal to 120. So this is also getting satisfied. X plus y greater than equal to 60. This 80 plus 10 greater than equal to 60. That means 90 greater than equal to 60. This is also getting satisfied. Okay. So we came to the conclusion that region number 2 is the required shaded portion. Now see, what are the corner points? Corner points are your 60, 0, 120, 0. This your 60, 30. Now since you have plotted it on the graph, you will be able to easily locate it. This is 60, 30. And this one is your 40, 20. Okay. So we got 4 corner points and we will apply the corner point method for this objective function. 5x plus 10y. For this corner point, we'll get z 300. For this 120, 0, z is 600. For 60, 30, z will turn out to be 300 plus 300, that is 600. And for this 40, 20, z will be 200 plus 200, that is 400. So we were supposed to find both maximum and minimum. So here we go. This z is equal to 300 is the required minimum value, okay, which is occurring at x 60 and y 0. And the maximum value is occurring at 2 points. So such case we have discussed in the previous question also. So when the maximum value is occurring at 2 points, that means it is occurring at 120, 0 and 60, 30. 60, 30. That means this maximum value, same maximum value will be occurring at this complete line joining these 2 points. So how do we write it as? That maximum z occurs at line joining points 120, 0 and 60, 30. So maximum value of z is 600 for this question. Thank you.